Hi everyone, welcome to Innovation Talk series, which is prepared and proudly powered by Turkish Airlines Innovation Team. In these sessions, we have very hot topics like data science, machine learning, artificial intelligence, and etc. We hope that this program enables you to provide value for our Turkish Airlines family, as well as the innovation ecosystem in general. Today's topic is supply chain planning and operational planning. If you are ready, dear colleagues, I'm honored to introduce you to Professor Dr. Metin Türkay, who is the Department Head of Industrial Engineering at Koç University and co-founder of SmartOpt. Today also we have Soner Babiroğlu as the CEO of the SmartOpt. Please enjoy.
Hi. Today, in the fourth installment of our series, I'm going to talk about supply chain optimization and also optimization of operations. The first two lectures focused more on the foundations and fundamentals of data science. Then in the third lecture, we talked about the logistics operations and optimization of logistics systems. And in the fourth installment, we are going to talk about supply chain operations that spans strategic objectives, planning activities, and also the operation of supply chains itself. Let's review the foundations of supply chain with you. With this simple diagram. Supply chains actually vast structures that encompass the suppliers, the manufacturing sites, and also distribution centers, retailers, and customers in itself. As such, they span global, proportions, and also some of the decisions that are contained within the supply chain may span several minutes up to several decades. Consider, for example, the supply chain of an aircraft. So in order to manufacture an aircraft, what we do is we come up with enormous structures, the determination of supplier bases at different geographies worldwide, and also we have limited number of manufacturing sites. And when we establish the structure, usually we keep it for 20-25 years. This is the cycle where the aircraft is renewed. But on the other hand, if you consider the operations of, catering operations in an airport or airplane, in this case, the cycles, renewable cycles of the supply chain configuration may take several, months, because we want to keep everything fresh in season. So we have an example in the sector that spans 20 plus years. The other one is 2-3 months. But the underlying structure and flow is the same. So in this case, in the supply chain case, we have a global, network of suppliers. And also in the second, echelon, we have the manufacturing sites where we convert these raw materials into desired forms by the customers. Then we have the distributors where we store it until we deliver to retailers. Retailers usually send all of this material to customers. So typically we have different performance evaluation criteria for end-to-end supply chains. Traditional approach has been to focus on financial goals. In the case of suppliers, we have raw material purchase price as the dominant figure in our costs, but in the manufacturing, production-related costs like labor, like the utilities, like amortization of the equipment that we use for production are the dominant factors. Then we have the distributors where we handle material and inventory holding costs, especially the rent of the space that we are going to pay at the warehouses, and also maybe some equipment that we are going to run, plus labor cost, material handling cost. Then retailers actually is where we serve the customers. And in this case, customer service is very important. Again, the rent of the facilities that we serve the customers could be an important factor. And all of the activities are actually fueled or made it possible by the revenue that we receive from the customers. So this is the financial centric look at the supply chain. However, in the 21st century, we have to look at the environmental footprint, environmental impact of supply chains. And usually raw material quality with respect to suppliers become a major, concern. Because depending on the quality of the raw material, we may be emitting a lot to the environment, right, in the form of gas, liquid, and solid. Then production efficiency at the manufacturing site is very important because production centers consume a lot of energy, and also they have a lot of equipment that may be emitting a lot of carbon dioxide and harmful pollutants to the environment. Then distribution center has the dominantly storage systems, and retailers are mainly packaging is important because when we serve the customers with these goods and materials and services, we want to serve them in good packages. So packaging is important, and also at the end of the life of the customer consumption of the service or the product, waste is generated usually. So how do we handle the waste is very important. So our perspective on end-to-end supply chain is not only financial centric, but also we focus on the environmental impact, and as I will illustrate in a minute with some examples, and social impact as well. Not only financial, but the environmental and the social impact are also important constituents of end-to-end supply chain management. Then traditional view of flows in any supply chain has some assumptions. It assumes that the product or material flows from one location to another, right? Usually from supplier end to the customer end, and the data flows in the opposite direction. Means that customer generates the data and it goes to the supplier. And also the cash in the system is generated by the customers, and it is basically sent to the entire supply chain. However, in the 21st century, the flow of material information, data, or the cash is bidirectional. So it can go in any direction. Therefore, perspective for holistic, operations of supply chains must consider bidirectional flows of material, bidirectional flow of data, and also bidirectional flow of cash. Okay, so this structure, supply chain structure, is very complex. So this complexity brings a lot of challenges with itself. So the first category of challenges is uncertainty. And at every step, every echelon of the supply chain, every function, every flow, there is uncertainty. But there are two uncertainties that are dominant. One uncertainty is at the customer end. At the customer end, we don't know what will be the demand by the customers. And also, we don't know what is the price that the customers are willing to pay. Therefore, there is uncertainty in the marketplace. So this is one important source of uncertainty. The other source of uncertainty is on the supply side. So on the supply side, we are not sure what quantity that we are going to receive, what will be the price, and what will be the quality of the products or parts or service that we are receiving. So these two ends of the supply chain actually brings us the largest uncertainty. So COVID-19, for example, has strangled all of the supply chains dramatically because traditionally supply chains were configured to absorb the demand uncertainty on the marketplace, on the customer side. However, with the emergence of COVID-19, not only the markets changed because everyone's lifestyle has changed because home became workplace for many of us, still continues to be the norm now because we are working from home, telecommuting. But also, the supply side changed. With the globalization after 1990s, what happened is most of the manufacturing went to China. And the source of COVID-19 was China. Therefore, many countries restricted flow of transportation from China to their countries. Moreover, China also closed some of the production facilities. So most of the ports were closed. Flights could not fly. Therefore, there is a uncertainty on the supply side that the supply chains were not configured for. So imagine that you are boxing, you are a boxer, and you always, expect one punch from one side from your opponent. So supply chain actually simultaneously threw two punches. Right, so that's why supply chains are suffering greatly, and they are going to continue to suffer to some extent, in the near future. Therefore, uncertainty is very important. How do we characterize and understand uncertainty? So we discussed about forecasting in lecture number 2, and there we talked about data science based approaches and models for reducing the uncertainty, both in the price, also on the demand side. And these approaches can be applied to marketplace as well as supplier side as well. So this will help us a lot in terms of reducing the uncertainty. But yet we have other challenges that are still in place. First of all, customer expectations. Customers' expectations are very dynamic and changes very frequently. Sometimes, customers are willing to wait for service. Sometimes they are not, depending on the segment of the customer, depending on the economic level, and also busyness of the people. It may change, So how do we adapt the expectations by the customers? So customers always are expecting more. And some industries are driving these expectations. For example, mobile or smartphone industry. They are always, raising the bar. The same price, but quality improves every year by 20, 25%, 30%. So customers are expecting the same rate of innovation from our products and services while keeping the prices the same or even lower. Okay. Capacity limits. Every system in this entire network has limits. So, however, we have to have flexibility to respond to uncertainties and customer expectations. We cannot if the capacity is not configured to be flexible to that extent. So, under capacity limits, what do we do? Difficulties with simplified solutions. So, this very complex system, we are trying to find a solution, make decisions, and over the years, we adopted some solutions that focused on one aspect, either one segment of the supply chain or echelon of the supply chain, or one function or one flow of the supply chain. Now we have to integrate them, because without integrating them, we will not be able to establish a holistic view of end-to-end supply chain. But when we try to integrate them, there is a problem. The problem is these pieces cannot come together very easily because nature of the models and algorithms are different. So making up a whole from simplified solutions may not be possible. It's a very difficult and enormous task. Then application of systematic solutions is also a challenge because we need talent, we need tools, we need insight, we need a long-standing understanding of the issues. So that's also scarce, very scarce. I mean, thanks to data science, we have been able to make tremendous progress in understanding the data and converting this data into, useful models. But, we want to make decisions to improve our system performance. But in that case, this is a high-skilled area. High, expertise is required, and that's lacking. the problems have not been solved, so far, so that we have a stock of knowledge in decision making. So application of the systematic solutions may be very difficult. Then monitoring and performance evaluation. Traditionally, we monitor only the flow of transactions, the capital, and we measured almost everyone's performance in terms of the financial value. However, in the 21st century, in addition to these, we have to monitor and evaluate environmental performance. We have to monitor and evaluate social performance. In this case, what do? We have to have procedures, models, metrics, and solution algorithms that will accommodate this multifaceted and multidimensional picture of the decision-making process. Then, sustainability of solutions. When you implement a solution, it's like a living organism because it has to be updated, renewed, refreshed, readdressed. Maybe capacity could be increased. Maybe it has to be integrated with other functions that we are not seeing now. So it's like a living system. So how to make sure that it is sustainable? The solution that we provide is sustainable. It will serve us in the coming picture. So in this case, we have this holistic perspective where we have the different layers supporting each other, right? So we have the data acquisition layer, then data warehousing layer. Thanks to recent developments in especially cloud computing, data warehousing and data services became very strong. So data is available everywhere. Even if you are flying, you should be able to receive all of the data with the connection that you have at the on the airplane. Then we do data mining to identify what is valuable in the data. Then we convert this data into different models using machine learning algorithms. Then on top of that, there is the optimization. Optimization gives you the best possible course of action given all of the vast alternatives and also all of the models that are provided to you by machine learning. So if you consider all of this, pyramid, a decision maker, how can I make sure that I'm making right decisions? I'm incorporating all of the possibilities. So obviously, if you want to do it yourself, in that case, you have to master all of these skills, or your organization must possess all of these skills in its portfolio. It is almost impossible. There's no company in the world, no organization in the world that has everything. Right? In that case, what you do is you work with different experts, support different layers of this framework. And also, as decision maker, you want it simple. No matter what how complicated is the problem, you want a simple decision-making approach. That's the decision support layer that we have on top of everything. Okay, so now I'm going to illustrate some applications of this holistic approach. The first application area is supplier evaluation. So it is one of the most important segments of the entire supply chains. So how do we evaluate our suppliers? So my goal is to support my decision-making process and have the best overall supplier selected for a product or service. But in this selection, I don't have one criteria. I have multiple criteria. I have 5 broad categories of criteria. One of the criteria is cost, right? So it has to be cost effective first. Then next factor is whether environmental compliance is observed with this company or not. Not only compliance, maybe I want them to be better than legal limits in this case, right? Then social performance. Then the soundness business plan of my supplier. Then whether this supplier could be integrated into my end-to-end supply chain or not. So 5 broad categories, but each category has different subcategories. And also there may be many alternatives, right? So it's a very complex decision-making process when I evaluate one supplier. However, it is highly critical because most of the time, if you are the brand owner, in this case, end customer will reflect the failure by suppliers, shortcomings by the suppliers on you. Because you are the entity who is facing the customer, who is making the service available to the customer. You cannot say that, okay, I mean, for example, catering services, we are usually very good, top notch, catering, airline. However, we had some, ingredient issue. One of our suppliers was not able to provide us with a high quality, product. Whether we are not offering it at all, it means that customers will not be happy because they will not be getting what they want, or you will serve second quality, product to your customers. Customers would not, understand that this is the fault of the supplier. No, it's your fault because you are the one who is facing the customer. You are the one who is offering the service or product to the customer. Okay, so in that case, close relationship and integration of all of your customers to your system is essential. So you cannot escape from that. Usually, supplier evaluation may happen at one shot, or it may happen in rounds. So you have to have a decision-making a framework where supplier is evaluated only once or several rounds. But this process is not very easy to configure because it is a very complex mathematical problem. We have 5 different main decision criteria. Then I have to evaluate maybe several suppliers, and also I have to do this for hundreds, maybe thousands of different products or services. If I do it once, what happens is I solve this problem once, and with the data science I get all of the parameters, and with the help of optimization technology I identify actionable and acceptable solutions, maybe the best solution if you are lucky. So in that case, you can do it at one shot. However, if you do this in rounds, in the first round, what you do is you evaluate and you screen out several of the alternatives because there will be some outliers that will be lagging behind. So you may remove 1 or 2 suppliers. Let's say that you have 10 initially, 2 are removed it in the first round, right? So in the second round, you have 8 suppliers. And in the second round, you evaluate even deeper. You benchmark these suppliers against each other, and you reduce the number to 5. Maybe third round, 2 or 3. And final selection is always by the decision maker, right? So this is a very healthy process where you benchmark all of the suppliers against each other, and also you provide feedback to your suppliers so that they become ready. They get ready what's coming next, because usually when we select suppliers, we have these agreements for 1 year or at most 2 years. So in this case, 2 years later, if the supplier wants to continue to do business with us, from today, they know what we are looking for. So they can start improving their operations. If their social performance is lagging behind, maybe they can improve their social performance. And next year, they can be more, compatible challenger to receive the contract. Or one, contract owner barely, won the contract, and the decision criteria, 1 of the 5, was very close with the competition. In that case, they can say that, okay, next year I have to improve this because competition is catching up. So this is very healthy. So our suppliers are going to improve or increase their levels. At the same time, we are going to have a better coordination. At least our suppliers will understand what we are looking for and what we are prioritizing, right? So this is an important problem in supply chain management. The second problem that I want to illustrate with you is network design and upgrade. So here I have an example application in Turkey. It is regarding an ecological product, organic agriculture product. So in this case, we are trying to find locations to cultivate and also process this product and possibly bring it to marketplace. So main customer destinations are given here. For example, Ankara, Istanbul, and Trabzon and Samsun are main destinations. Antep is main destination for organic food as well. So what we try to do is to establish a network structure. But network structure is a little bit more complicated. First of all, we are not looking for profit maximization only. We are trying to find a solution that is environmentally friendly, a solution that improves the social impact of our organization. So for this, we have to go through a very long checklist. Checklist is what will be the decision criteria. The first decision criteria is, of course, as business, we have to make profit. Without profit, we are not going to be able to sustain our business financially. Second, environmental impact. So we should not pollute the environment first. Make it better. If we cannot make it better, do not harm, right? The environment. This is our motto. So for this, maybe we will be inclined to select locations that has access to geothermal energy, for example, or solar energy, wind energy in this particular example. So environmentally friendly. Third is social impact. For example, you see that there is there's a high level of activity in southeastern part of Turkey because unemployment is high. So what we try to do is we want to generate social impact in this region, right? So first, decision criteria. So what are the subcategories in this decision criteria? We have to know. We have to get data for it. And second, we have to check whether the decision criteria that we think of is relevant or not. We do this through statistical analysis using data mining techniques and data analytics technique, machine learning techniques. However, we have to ask, we have to involve the stakeholders. Our stakeholders are in such investments, network structure, central government, because central government wants investment. Every central government in the world wants investment in their country because it's going to, reduce the unemployment. It is going to basically bring in some cash and credit to the economy. Economy will be lively, and also maybe tax revenues are going to increase. So it's very good from the government perspective. Then the country, people, that lives in the country or the geographical region. So they will be happy in most cases, and in some cases they will not be happy. They will be happy because there will be investment and progress. And this is very true for developing countries. So they want progress. But for developed countries, they want stability because, they already have a lot of, wealth in the society. So they don't want this disturbed and changed. They don't like the changes a lot. So we have seen this in many developed countries. They are against immigration, etc., because they are stable. They don't want this stability disturbed. Then the local people. So there is an investment. You're very happy because probably you are going to have access to some opportunities. Maybe your family members will find some employment in this facility. Maybe schools will improve because there will be a lot of investment in the region. Healthcare system will improve. Roads will improve. Infrastructure will improve. Maybe telecommunication infrastructure will improve. Maybe local shopkeepers will be happy because there will be more people and there will be more sales, expanded sales, right? Their business will grow. And there is the, non-governmental organizations. Non-governmental organizations are stakeholders in this decision because they want to make sure that the long-term sustainability of the society and financial system and also environment is observed and respected with these decisions and investments. Therefore, so it is a multifaceted, multi-stakeholder problem. You can solve this problem only by incorporating all of these people, stakeholders first. Second, making sure that right decision criteria are defined through innovative data mining techniques, statistical analysis techniques. Third, making sure that your solution algorithms are able to address this complex optimization problem in multiple dimensions, incorporating multiple stakeholders. So actually we have a very consistent and well-tested system for network design and upgrade problems. So as you can see, we have an example here. The example is the solution that you see on the map in the previous slide. What we have is we have three different criteria, and our criteria are the blue is environmental criteria. So economic criteria. As you can see, economic criteria is not very sensitive. No matter what happens, we are within 2%, right? 98 to 1%, range, 98 to 100% range. So our optimization in terms of environmental economic criteria is going to be here. Then the second criteria is environmental criteria, which is the red, lines, right? So in this case, we see a very strong variation depending on the solution. And the last one is a social utility value. So what is my contribution to society? What is my contribution to the employees? So it is the measurement of this. As you can see, a decision maker can easily pick a solution among these solutions, and among these solutions I can select one that will give characteristics of all of the solution parameters. So where do I locate this facility? What will be the capacity of this facility? What is the technology that is used? Which markets are served from this facility? So you need consistent tools to support this complex problem. Okay? So this solution framework is collected under a net opt solution. Net opt solution, you have the demand forecast and price forecast. You have the market conditions, you have the financial data, production technology, transportation infrastructure, everything. Then you collect all of this data and establish your model, and this model is basically incorporating different decision criteria. Whether you are going to favor only the financial characteristics of the solutions, or at the second level you are going to incorporate environmental characteristics or social characteristics, or you want to have a holistic approach. You want to see the problem in three dimensions. What will be the environmental impact, financial gains, and also the social utility to entire society. So you want to pick the solution that will balance all these parameters all together, right? Then you have to find the optimal solution to this problem. So this algorithm is very robust. All of the models and algorithms are tested rigorously over several very challenging problems. So far we discussed the strategic level decision to select a supplier, because supplier is like a partner for you. So it's a long-term decision. Usually you start with 1 year, then you extend it to 2 years, and afterwards, it's like a lifetime commitment. So it's a strategic decision. Then network structure is also a strategic decision. Now the second level of decisions are planning decisions that are happening at the midterm, right? So in this case, we make decisions on production level, capacity adjustments to absorb seasonal fluctuations, plan workforce, manage inventory, and determine inventory policies. Then subcontracting decisions, managing back orders, planning the demand, and training of employees for what is next. So this is a planning activity, but it has different decision criteria. Not only we consider financial factors in terms of revenue and cost, we also incorporate environmental factors into decision-making process. So first category is the carbon footprint. So subtopic are carbon taxes and also carbon capacity limits, so emission limits. Right? Then energy consumption. So energy consumption per customer, product, or service that we serve, right? So in the previous example, we had one investment in Turkey map, because that was selected because the geothermal energy was located in the vicinity. Therefore, our carbon footprint was reduced dramatically with the selection. So you can see the compromise between different approaches. So social factors. So this is also a human-centric approach, although models, algorithms, and automation is displacing workforce, slow by slow. What happens is, these systems are for humans. So what will be the impact of the solution on the employee, especially employee morale and motivation? So what is the turnover rate? Are we laying off employees, or are we hiring employees? How frequent is this? Then employee health and work-family balance, right? So are we asking continuously our employees to work overtime, thereby destroying their balance in the family because they have to spend some time with their family as well, right? So all of these decisions are interrelated. We apply this approach on a production electronics manufacturer in Turkey, and in this case, what we saw was if we were aiming only the environmental compliance and improving our environmental impact, the added costs are going to be 4.4%, 4.47%, right? And in addition to this, if we are adding the social, in that case, added cost is going to be 2.47%, right? So if we implement these solutions separately, independently from each other, you can see that it is going to be approximately 6.94, right? 6.94%, increase in costs. However, if you have this holistic approach, what happens is added cost is going to be 6.51, right? So in that case, 0.5% gain by this holistic approach can be obtained. So these approaches actually are recently, collected in the book that I published last month. So these models, especially for planning problem, models, algorithms, in addition, the Python codes for these models and algorithms are available in this textbook. So it is mainly targeted as textbook for training of young professionals and interested people. So you can download it, you can test the algorithms and models. So the algorithms and models that are contained in PlanOpt are advanced versions of this, supported more with data science and better algorithms. But the textbook model is going to be a starting point for you to experiment different ideas. So in this case, we combine all of the demand information, right? Supply related information, logistics infrastructure, your financial data, employee database, right? And combine this into a single model. This model again has a balanced overview of social, economic, and environmental factors, and you are able to solve this problem effectively. And displaying all of the information, the solution part. If you pick a particular solution in this high dimensional space, you will be able to see what are the underlying characteristics and what are the compromises that you are making with respect to financial performance, economic performance, and social performance. The last example that I want to share with you today is inventory and route planning. For global operations, what you have to do is to, make sure that all of the different transportation modes are integrated into a single model, right? So inventory, where is the inventory located globally? So how can I, meet the service requirements with the inventory that is available at hand? So this tends to be a very complex, optimization problem. So you have the supplier side, supplier feeding the Tier 1 could be a port or airport. If you are using sea transportation, it is usually port. And if you are using air transport, it is usually airport or warehouse next to the airport. Then afterwards, by using different modes, what you can do is you can use a Tier 2 supplier, which is mainly the distributor. Or in some cases, you can directly receive material from the Tier 1 supplier. This is a very complex problem because we are always trading between two conflicting objectives. One of them is the cost. The other one is service level. We want to maximize the service level. It means that if you maximize the service level, safety stock is going to be very high. So these will be in conflict. If I want to increase my service level, I have to incur a lot of cost. So it means that my system is going to be very expensive, not affordable by some of my customers. Then the second layer is inventory policies. Can I define my inventory policy? Periodic review policy or continuous review policy. And also, can I match this with information flow? With the information flow, I have to be able to see and monitor where are the parts located, where is the material, right? So there is basically a very high, collaboration between supply chain and also emerging technologies such as blockchain in this case for information flow model. Then in the last case, what you can do is to incorporate shipment schedules. Shipment for sea transportation, rail transportation, and also air transportation. So this system is contained within the inventory opt framework, where you have the production plan at your facilities or service plan, and all of the information regarding the supplier network, right? The production capacities, logistics capacities, inventory levels, and also the financial data. Then you bring all of this data into a model, and model should be able to support multiple, sometimes conflicting goals or objectives. And you solve this problem and basically obtain a solution to your complex inventory management problem. Where are you going to locate? What will be the quantities? What will be the safety stocks? What will be the incorporation of schedules, shipment schedules into your decision-making process? So this is the fourth day of our series of talks. We covered the fundamentals of data science in the first two lectures. The first lecture is the fundamentals. The second lecture is how do we manage the forecasting problems. This third was on the logistics operations. The last, we had a broader perspective of supply chain management. Certainly, this has been a pleasure for us to share our insights and expertise with you. We thank everyone at Turkish Airlines to giving us this opportunity to talk to you. We will be very happy to see that we inspired some innovation in you, and we look forward to brighter future with you.
Thank you very much for sparing your time to join us in this session. We hope that you enjoyed accompanying us during this visionary training. If you have any ideas about the content of this session or relevant project ideas, please don't hesitate to reach us at innovation@thy.com. So for now, goodbye as we plan for the next sessions of the Innovation Talk series. See you.